Okay, so we're going to do some combined gas law practice, and as I read these problems, I'm going to go ahead and I'm going to pull out the individual variables and define them off to the side. So it says if a gas initially took up 47 liters. Okay, that word initially and the unit liters tells me that this is my V1 number, and it is 47 liters. When the temperature was 270 Kelvin, so that's still my T1. I have a past tense, my before being 270 Kelvin. It says what temperature, so that question word attached to, what volume. I have that question word attached to the unit volume, which means I do not know what that is. Does it occupy at 298 Kelvin? So that is going to be my T2. That is my after temperature, so that is 298 Kelvin. So I'm going to take my initial combined gas law equation, which is P1 V1 over N1 T1 equals P2 V2 over N2 T2. And I'm going to go ahead and I'm going to take out any of the variables that I do not see. I do not see pressure, and I do not see moles. So I'll ignore those and I'll rewrite that equation. V1 over T1 equals V2 over T2. It's the weirdest T I've ever written. And I'm going to go ahead and I'm going to isolate for the variable that I actually care about, which is going to be V2. So this is the variable that I care about. I see that it is currently being divided, which means that I need to multiply both sides by T2. When I do that, my new equation will be written as this. V2 equals V1 T2 over T1. Whenever we multiply, remember it goes on the top of that fraction there. And now I'm just going to go ahead and I'm going to plug everything in. So I see my V1 was 47 liters. And I'm multiplying it by my T2, which was 298 Kelvin. And I will divide by my T1, which was 270 Kelvin. I'll cancel out any units I see at the top and the bottom, so that would be Kelvin. And I see that my only unit left is liters, which is an appropriate unit for V2. So I can go ahead and plug that into the calculator. When I do, 47 times 298 divided by 270 gives me the number 51.87407. This number is gross. I'd like to round it. 1, 2, 4 is the last number that I'm going to look at to see if I need to round up. 4 does not make me round up, which means that my final box answer would be 51.87. I need to include a unit. The only English left in my math is that liters, so I will go ahead and attach it there, which means that my final answer for V2 is 51.87 liters. Okay, this problem says the pressure was 3.2 atmospheres. Was implies there was an initial, so P1 is equal to 3.2 atmospheres at 123 Kelvin. So these two numbers are connected at the same time. We have that was word, so that means that T1 is going to be that 123 Kelvin. What temperature is needed to produce? So I'm asking for temperature. I'm looking for T2. I don't know what it is. A pressure of 16 atmospheres. So P2 is going to be 16 atmospheres. And I don't know what T2 is. Again, I'm going to go ahead and I'm going to write down the initial combined gas law equation. And I'll eliminate any variables that I do not need. I do not see volume at all, and I do not see moles at all. And I'll rewrite this as P1 V, oh, no I will not, V got canceled. So P1 over T1 equals P2 over T2. Okay, now that I have this, I can go ahead and figure out what I need to do. So I'm looking for T2. This is the unit that I care about. This is a variable that I care about. So I need to isolate that. This is going to be a little bit more tricky. T is currently the one that is dividing, which means I need to both multiply both sides by T2, which will eliminate it from this side. That would leave me with T2 times P1 over T1 equals P2. I see this here. I'm going to go ahead and I see that T2 or T1 is being divided on this side. So I'm going to go ahead, I'm going to multiply T1 to get rid of it on this side, which means I'll multiply T1 to move it over here. And then I also see that P1 is multiplying T2, but I want T2 alone. So I'm going to go ahead and I'm going to divide by P1. If I divide by P1, that will leave me with T2 equals P2. Multiplication will stay on top of the fraction line, and I'll divide by P1. Now that I have this isolated, I can go ahead and plug everything in. P2 is going to be the first number that I plug in, and that is 16 atmospheres. And I'm going to multiply that by T1, which is 123 Kelvin. And I will divide by P1, which is 3.2 atmospheres. Atmospheres will cancel, leaving me with the unit Kelvin, which is an appropriate unit for temperature. So that looks good to me. And I could go ahead and plug everything in. So 16 times 123 divided by 3.2 gives me the number 615 Kelvin, and that's a nice enough number. I don't feel the need to round, so I'm not going to, and I'm just going to go ahead and box that answer and move on. This next problem says if the initial volume was 18 liters. So that very nicely told me that it was my V1. My initial volume was 18 liters at 4.3 atmospheres. Since we are connecting these two things, I know that that is going to be my P1. What volume means my V2 is unknown? Would the gas be at 2.15 atmospheres? So that's my P2. And then I'm going to go ahead and I'm going to write down the initial combined gas law equation. And I will eliminate any variables that I do not see. I do not see moles. I do not see temperature, so I will rewrite this as P1 V1 equals P2 V2. And I am solving for V2. P2 and V2 are currently being multiplied, which means that I need to divide both sides by P2 in order to isolate V2. So whenever I rewrite this equation, it will be V2 equals P1 V1 over P2. And I can go ahead and plug everything in. P1 is 4.3 atmospheres. V1 was 18 liters. And P2 was 2.15 atmospheres. Atmospheres appears at the top and the bottom, which means that I can cancel. And I can go ahead and plug everything in because the only unit left in my math is liters, which is an appropriate unit for volume. So I can say 4.3 times 18 divided by 2.15, which gives me another really nice number of just 36. And then I just need to include that unit, so 36 liters would be my final boxed answer for that. Here we have our last problem. It says the pressure was 5.6. That was implies that this is my initial pressure, and it is 5.6 atmospheres. At 298 Kelvin, again, this implies that they are interlinked. Was implies that it is my initial, so that means that is going to be my T1, and it is 298 Kelvin. What temperature is needed to produce? So that means I need to know my T2. A pressure of 18.7 liters, 18.7 atmospheres, that would be very strange. So P2 is going to be 18.7 atmospheres. I will write my initial combined gas law equation, and I'll eliminate anything that I don't see. I don't see volume, I don't see N, I don't see volume, I don't see N, which means that I just have pressure and temperature again. And so I'm gonna go ahead and I'm gonna isolate for T2. We did this once before, so it should be pretty familiar to you. I'm gonna go ahead and I'm gonna multiply both sides by T2, which will eliminate it on here. So T2 is being multiplied by P1 over T1. I'm going to divide by this fraction. When we divide by a fraction, we need to multiply the other side by the reciprocal, or we need to multiply both sides by the reciprocal to get rid of it, which means that I will multiply both sides by T1 over P1. And that will allow this to cancel, leaving me with T2 being set equal to P2, T1 over P1. And so now I get to plug everything in. My P2 was 18.7 atmospheres. My T1 was 298 Kelvin. My P1 was 5.6 atmospheres. Atmospheres appears at the top and the bottom. The only unit that's left in my math is Kelvin, which is an appropriate unit for temperature, so that means I can go ahead and plug everything in. When I do that, 18.7 times 298 divided by 5.6, that gives me the number 995.1071429. That's a really long gross number. I don't like it. I'm gonna round it to 2 decimals. 1, 2, this is the last number I care about. Look over to see if I need to round up. 7 does in fact make me round up, which would mean that my final answer would be 995.11. Make sure to include your unit, which would be Kelvin.